Greetings, Math 111. This is going to be section 1.3. I wanted to first start by pointing out that formula sheet that I mentioned in section 1.2. If you go in Canvas, go to the course syllabus tab, you will see the syllabus, the lecture schedule. You'll see some other helps that are available. If you scroll down, you see T and X charts with formulas. I have a whole bunch of copies of this, different times I've scanned it or created them. I have some other varieties I will add also. Again, I'm gonna add them someplace else too. But if I click on that, I have these formulas. So it'll be something that looks like this. You'll want to print that out and have that available. We will not use chapter 11 and we will only use a small part of chapter 10. I will probably also, if you go under modules and you see this resources tab that right now doesn't have anything in it, I will add some resources there as well. I always want to make sure you have, you're self-sufficient enough to find the right tools. All right, section 1.3. Let's jump into this. So, introduction to experimental design. So, let's say you are a psychologist, a sociologist, perhaps you work for the city planner, maybe you work for the police department, maybe you're a political science student, and you have to create some sort of study that pulls together data, and it has to be well thought out because these things are expensive. You may have to pay people that are in the study in order to come and answer you. If it's some sort of medical study, you have to pay for their medical bills as part of the study. You may have to pay travel, you may have to pay hotel, so you've got to do it right. So how do we do that? How do we make sure that we design it correctly? The first thing you do is look at studies that other people have done. So they'll lay out their procedure, they'll lay out the steps, and then at the end, they usually go through and analyze. How did that go? What would I do different? Because you can't change in the middle of a study. However you start, that's what you gotta do. You can't change it. So you're gonna start in a certain way, and then you're gonna work your way through. At the end, you can analyze what you did wrong. And often, especially if it's in some sort of professional journal, there'll be people that criticize in a positive way, as in making it better. So, introduction to experimental design. So discuss what it means to take a census. We're in the middle of that right now in our country. Describe simulations, observational studies, and experiments. Identify control groups, placebo effects, completely randomized experiments, and randomized blocks of experiments. Discuss potential pitfalls that might make your data unreliable. Okay, so planning a statistical study. So we're going to plan a statistical study and gather data in order to have good results that are reliable, that we can make decisions on. We've all heard in the news, all the criticism is they made decision on studies that were done poorly or incorrectly or didn't make sense. So I'm going to quickly read through these steps. So identify the individuals or objects, specify the variables, and how are we going to take those measurements. One time I actually had a nurse in my class that worked in a nursing home, and part of her job was to do surveys with the residents. And she said, I never knew until we had talked about this in section 1.3, why I have to read the questions exactly the way they're written. Like, they're not allowed to change the questions. They have to answer them that way. There's only certain results or responses allowed, and that's it. So how do you do that? Determine whether you'll use the entire population or some sort of sample. And if it's going to be a sample, what's the right sampling method that we just talked about? In your data collection plan, address issues of ethics, okay? If I'm going to have high school boys stripped down to their underwear and weigh them for wrestling, do I let women in the room? Does their coach have to be there to protect them? Does their parent have to be in the room? What's appropriate? Is it appropriate to put them up on a stage? I understand that that's the system today. It's kind of crazy to me. Confidentiality, who gets to see the data? Are they just a number in the study so that nobody can trace it back and only one person has the correlation of what the name is and what their number is? Privacy, if you're storing data at a business, store, college, or other institution, be courteous. And if you're collecting data from a business, college, store, or other institution, be courteous and to obtain permission as necessary. Almost every organization has rules, just like medical has HIPAA laws, education has FERPA laws. So you have to make sure that you comply with those and you ask permission. So collect the data carefully, mind you. Use appropriate descriptive statistics. We're going to learn that starting in chapter 2. And then appropriate inferential statistics. It'll be farther out in chapter 8. Finally, note any more concerns you might have about your data collection methods. Maybe you're halfway through it and you go, man, I wish that we had bought a different scale. I wish that we had specified exactly what the people would wear. That maybe we have them put on the same hospital gown, to make sure that when we collect their weight, that we do it that way, and that we always do it at 9 o'clock in the morning, or whatever the procedure is. But make some notes about that. So in a census, we want to talk to every single person in the population. Every person. There are even Sesame Street commercials about the census, and I loved the count. Okay, I'm a math teacher. I'm really an engineer by trade, but on Sesame Street I loved the count. Okay, and so it's really fun to me that he's doing commercials about the census, and we want the entire population. In a sample, we take measurements or observations from part of it. Remember that little chart? We had the entire population versus the sample. Okay, experiments and observation. So in an observation, that's what we do. We observe, okay? Patiently wait to see what happens. An experiment, we do something, okay? If sometimes at Christmas time, there are news outlets that will say, what are the most popular toys out there? If they put a bunch of toys in a room and a bunch of 2-year-olds, and then just watch to see what toy they like, okay? That's an observational study. However, if they say, hey, look, maybe you get down on the floor, those with little people around you, you get on the floor and you start playing with the toy, well, that's what the child always wants to come play with, right? So that's an experimental study, okay? So you did something to change the way they might react, okay? They both have their purposes, okay? So in 1778, Captain James Cook landed on what we now would know is the Hawaiian Islands. He gave the islanders a present of several goats. And over the years, these animals multiplied into wild herds totaling several thousands, okay? The problem is, they weren't born there. They weren't native species, so that's always bad. Don't bring in non-native species. They eat almost anything, including the famous silver sword plant, which was once unique to Hawaii. At one time, the silver sword grew abundantly on the island of Maui, but each year there seemed to be fewer and fewer plants. Biologists suspected that the goats were partially responsible for the decline in the number of plants and conducted a statistical study that verified their theory. To test the theory, park biologists set up stations in remote areas of this, I'm not sure how you say that, Haleakala. It was the national park. At each station, 2 plots of land with similar soil conditions, climate, and plant count were selected. One plot was fenced to keep out the goats, while the other was not. So the only thing was different was the fence. Everything else was the same. And that's an important thing when you set up a study, is if you vary too many things, usually you only want to vary, usually only one variable. But if you vary too many things, then what made the difference? I don't know. What made the difference? At regular intervals, a plant count was made in each plot. This study involved an experiment because a treatment, the fence was the treatment, by the way, was imposed on one plot. It was the only difference. The experiment involved 2 plots at each station. The plot that was not fenced out off was the control plot, because that was normal. Normally the ghosts just wandered wherever they wanted to and ate whatever they wanted to. That's the control. The experiment was the one that was fenced off. So this was the plot on which the treatment was specifically not imposed, although the plot was similar to the fenced one in every other way. Same amount of sun, light, soil conditions, all those kind of things. So in order to do a study where you want to do an experiment, you've got to have a control that's nothing changed, and then you have to do something different. Okay? Sometimes that's tricky because if you think about like a medical treatment, the people want to see results. They want to try something new that's going to save their life. And if you say, oh no, you're going to be the people that doesn't get anything, okay? So how do you handle that? Well, we have to take into account something, it's called the placebo effect. Where did that word go? Here it is. For instance, in medical experiments, the placebo effect is the improvement or change that is a result of the patients just believing in the treatment, whether or not it's effective, okay? God made us these wonderful complex beings that have brains that can overcome amazing hurdles, right? God made us truly special. Our brains can decide that this medicine is gonna cure my headache or give me more strength or energy, and that's the placebo effect, because it may or may not actually make a difference. One of the favorite movies at my house is Space Jam. So, and maybe not so much now, my boys are bigger, but when they were littler, man, we watched Space Jam all the time. In Space Jam, at the end, there is this magic potion. Remember Michael Jordan's magic potion? And that magic water, as it turns out was just magic water, they all believed, the cartoon characters felt that that's what was going to make them better than the Monstars. Okay, if you haven't seen the movie, pull it up, it's pretty fun. Okay, so they believed that this magic potion was going to give them great basketball ability, and that's why wasn't that why Michael Jordan was so great? Because of this special magic juice? Well, it was just water, but they believed it, and then they of course go on to win. Oh, I shouldn't have given away the end of the movie. The placebo effect occurs when a subject receives no treatment, but incorrectly believes that she or he, in fact, is receiving treatment and responds favorably. Okay, interesting. So to account for the placebo effect, patients are divided into 2 groups. We have a control group who receives nothing. Maybe it's a pill that really is just a sugar pill or something. It's really nothing. And then the other group gets the real pill. And along with that, we want to do something that's called a double blind. So double blind, the person giving the medicine and the person receiving it, neither of them knows. So if you were a nurse that was handing out medication and you knew that somebody was getting a fake pill, you'd go, oh, here, see if that helps you. Or you might say, hey, try this. Or, take your pill, I think it'll really help you, okay? My voice gave away something, right? Again, we have these amazing complex brains that control our bodies and often can change the way they affect. All right, so a completely randomized experiment is one in which a random process is used to assign each individual to one of the treatments. So there would be somebody that knows, but they don't have any contact with these people, okay? So they never can give away what's going to go on. So let me grab a drink, just forgive me. So this is an interesting treatment. Can chest pain be relieved by drilling holes in the heart? I've never heard of that before. For more than a decade, surgeons have been using a laser procedure to drill holes in the heart. Really? Okay, let's see. Many patients report a lasting and dramatic decrease in angina, which is chest pain symptoms. Is the relief due to the procedure, or is it some sort of placebo effect, right? Stress often manifests itself as chest pain or tightness or hard to breathe or hyperventilating, okay? Stress can do that to us. A recent research project at Lenox Hill Hospital in New York City provided some information about this issue by using a completely randomized experiment. The laser treatment was applied through a less invasive catheter laser process. A group of 298 volunteers with severe untreatable chest pain were randomly assigned to get the laser or to not. Again, they didn't know. The patients were sedated but awake. They could hear the doctors discuss the laser process. Each patient thought he or she was receiving the treatment. That's how we did. The laser patients did well, but shockingly, the placebo group showed more improvement in pain relief. The medical impacts of the study are still being investigated. Really? So how much is in their head and how much is real pain? Okay, so interesting. It is difficult to control all the variables that might influence the response. One way to control some of these is through blocking. Now, some of you may have been involved in some sort of medical study. If you've ever seen one advertised, we're looking for people, and it's so specific. It sounds like you're like, cooking the books is kind of what it looks like. But if I don't ask questions about whether somebody is diabetic, and they're in a study that has to do with, shall we say, skin conditions and how you react to sunscreen, that makes a difference, right? So a block group is a group of individuals sharing some common features that might affect the treatment. In a randomized block experiments, individuals are first sorted into blocks, and then a random process is used to assign each individual to the block in one of those treatments, okay? There is a control group that gets the dummy in treatment. Again, here's a summary. This is our summary blocks. Gets a dummy treatment, enabling the researchers to control for the placebo effect. In general, a control group is used to account for the influence of other known or unknown variables that might be an underlying cause of a change in response. Such variables are lurking or confounding. So, is the person a smoker? Does the person drink alcohol? Does a person use drugs? Not pharmaceuticals, but drugs. Are they diabetic? Do they have sleep apnea? Are they obese, or are they anorexic? Or all those things can change the way your body functions. Randomization is used to assign individuals to the two treatments. That helps prevent bias in selecting members, okay? Maybe I really like you, so I really want you to get this treatment because I really think it's gonna help you. I can't do that, or that's bias. Replication means that if I redid the study, I would get very similar results, okay? That's replication. Okay, surveys. So, we've all seen surveys, we get them. First of all, very few people actually respond to surveys, and you have to decide how you're gonna do it. There's a process, what kind of questions. Often you use, you do a little trial. You take those questions and you try them on a small group and see if you got good results. Because usually you find that there was a question that was maybe a little hard to understand, or maybe it was confusing, or people thought there should be some different answers, or you just kind of needed to back up. So sometimes they do a small study with those questions and then try them on the bigger population. Because again, it's expensive. If you've gotten those phone calls where somebody that's getting paid to make phone calls is asking questions and you can only answer certain things, that costs money. There's something called the Likert scale. So maybe it's something like, they put numbers, and you have numbers that correspond to strongly disagree, neutral, agree, strongly agree. Okay, that's the Likert scale. Sometimes we have open-ended discussion type responses. It's really hard to take those and turn them into like results. Like how do I summarize that? There's a number of issues when you use a survey. Non-response, those are the people that don't respond, all right? That's a huge piece. Truthful, people may lie. It's an anonymous study. I don't really need to lie about how much chocolate I ate this week, okay? It's really not important, but guess what? I might, because I might be embarrassed about it, okay? Faulty, maybe you really don't remember. If you're asking me about something from the last year, I really might not remember. Hidden bias, the way the questions are worded. Back when I was a baby engineer for General Motors, I guess I was still pretty young. I got to go to a marketing clinic. So the 1994 Oldsmobile Calais, and they were still designing them, like the clay models. And we flew out to California. Guess what? Us General Motors people had to sit in the next room and watch the interviews on a TV screen. We were not allowed to ask the question. Why? Because we would probably introduce bias, okay? I love General Motors. I still loved all those years. I was there 20 years. I still, would be happy to buy General Motors products. Believed in what we did. I thought we did a great job. And there were people in this study that said, well, I wouldn't buy any American-made car, or I certainly wouldn't buy a General Motors product. And it was like, oh, stabbed in the heart, right? I very well could have asked a question in a way where there was some bias. So there are marketing people that's their job, is to ask those questions, okay? Vague wording, words such as often, seldom, occasionally, mean different things to different people, right? Interviewer influence, tone of voice, body language. Did you know that in the court system, they often have, if they have a child that needs to testify, they have dogs that will sit there with the child, and the child will sit there and pet the dog and tell the dog all kinds of things. But they wouldn't tell some, guy in a suit that's kind of big, scary guy, right? So that interviewer influence makes a big difference. Voluntary responses. Individuals with strong feelings about a subject are more likely than others to respond. If you have a complaint, you're much more likely to fill out a survey than if you just want a compliment. So all these things can make surveys very, very tricky, honestly. So there's lurking variables, confounding, data collection techniques. We've talked about some. What is best? Well, it depends, right? Again, look at other studies that are similar. Do a short study and see what happens. Surveys might be it's the only way to do it, okay? Observational, experiments, lots of cool things. All right, see you guys tomorrow.